Hey, I know this is a little bit late. I've been working full time and of course it's been pretty full on. The last part of the causes of depression, I wanted to actually try and get someone who is a registered psychologist or clinical psychologist to talk about brain chemistry and some of the theories around that. Instead, I'm going to read what I've actually written in the book. So please bear with me. So we have some brain research which helps doctors get a look at what is happening in the brain for someone who has depression. So they use such things as positron emission tomography, or PET, single photon emission computed tomography, SPECT, and functional magnetic resonance imaging, fMRI. I actually emailed a theoretical neuroscientist by the name of Mark Humphreys, and he actually cautioned against trusting the studies that use MRI because they're difficult to interpret. What he said was that they lack any theoretical motivation and so are largely just reporting differences they've noticed. But by testing a large number of differences and only reporting those that reach significance, such studies are bound to find some difference. There's some research that says that the hippocampus is smaller in depressed people, but that doesn't necessarily mean it's depression. They've also found that it happens with post-traumatic stress disorder, and there are other illnesses as well that can actually explain those findings. So firstly, I'm going to suggest that if you're interested in brain chemistry and how it causes depression, then do some of your own research. Go on to Psychology Today, which has a magazine online, and you can actually look up various articles, and I do suggest you find Professor Mark Humphreys' article. It's basically the culprit, looking for the culprit in depression. I'll give you the reference if I can find it after this. Anyway, so the brain has 86 billion neurons, but with these neurons being part of the problem, the question is which ones. So Professor Humphreys actually points in his article to, and I have no idea how to pronounce this, so I'm just going to pronounce it how I think, the lateral habenula. So this thing is responsible for the body's reactions to a stimulus. So where we might normally react to something pleasant or unexpected, this neuron tells the body that everything is normal. So in depression, one of the chief characteristics is the inability to feel pleasure. So anyway, the body contains neurotransmitters such as dopamine and serotonin. We've heard of these, the body's messengers, so they carry signals via the nervous system to neurons, or from the neurons to the muscles. The neurotransmitters well, a lot of people actually call them happy pills for the brain. And dopamine, it becomes activated when something good happens. It's also known as a reward chemical. It helps with motivation, purpose, and drive. It's released when we're about to achieve something and our needs are about to be met. It's commonly known for affecting our emotions and our sensations of pleasure and pain. There are various clinical trials which study dopamine and its effects. Serotonin is a natural mood stabilizer, so it helps to reduce anxiety and depression as well as improving sleep, digestion, and so on. Some neurotransmitters don't actually break down in the body. Instead, they're reused by the neuron in a process which is called reuptake. It prevents too much serotonin, for instance, from being produced. And this is where we have antidepressants, which are known as selective serotonin reuptake inhibitors, because they stop this process. It's generally thought that depression can be caused by low levels of serotonin. So, getting back to the lateral habenula, when dopamine neurons burst with activity, that's a signal that we just got something better than expected. And when the lateral habenula releases a burst of activity, it stops the dopamine and serotonin neurons from bursting. So it stops them from saying to the brain, hey, that was unexpected. So what happens when you're depressed is that the neurons burst too much and they send the wrong signals. So the brain isn't reacting as it should. So what it's saying is that it robs the brain of its access to these neurotransmitters. There's also another culprit, which is known as the glia. These glial cells provide support for neurons. When they go wrong, in the case of depression, they're depleting the body's reserves of potassium. So there's been some trials in the States using a medication known as ketamine. This was originally used as an anesthetic, but it's been trialled as a treatment for depression since the early 2000s. And now the US Food and Drug Administration has approved a drug called esketamine. The thing though is that ketamine may not work for everyone. So the point is that it's not always brain chemistry. Another cause, of course, is genetics, and people believe that it can be passed down. If there is a family history, you probably are more likely to get depression, but not necessarily. Genetics, I think, plays a very small part in depression. Anyway, I do suggest you go online and on Psychology Today and have a look at some of the articles. Just read everything you can get your hands on if you're really curious about what causes depression and how to manage it yourself. So Professor Mark Humphreys, he's a professor in the UK, and he is a theoretical neuroscientist. So anyway, I hope that helps a little bit. Sorry for the jumbling mess. But feel free to comment if you've got any questions, and I'll send you the link to the article. Thanks. Bye.